Okay, I'm going to explain two things here. First of all, how to draw a light diagram, or a ray diagram, as it's otherwise known. And I can use this ray diagram to explain something called the law of reflection. So I'm going to start off with a flat reflective surface. It isn't quite flat, but that's because of my inability to draw a very straight line. But just imagine that is absolutely flat. It could be a mirror, it could be a sheet of metal, sheet of plastic, but it's a flat surface and it reflects light. All flat reflective surfaces will have something called a normal. And a normal is an imaginary line which is set at 90 degrees to the plane of the reflective surface. All right. Now let's bring light in, light camera action. So here we have a torch. And my torch is going to shine a light at my reflective surface. And to show the direction of travel of that light, we use a little arrow. And this ray of light is called the incident ray. And what happens when the incident ray strikes my reflective surface is, of course, it is reflected. And again, we show the direction of travel of that ray of light by using a little arrow. And this is the reflected ray. Now this will make fairly intuitive sense to you, but if you were to measure the angle between the incident ray and the normal, and if we call that angle I, we would find that that angle is equal to the angle between the normal and the reflective ray, which we can call R. Okay? I is equal to R. I is what we call the angle of incidence. And R is what we call the angle of reflection. So at all times I equals R. So for example, were we to change the angle of incidence by changing the angle of the incident ray, like this, then that would affect the angle of reflection, like this. Okay, so again, I would be equal to R. And indeed, the fact that those two angles are always equal is what we call the law of reflection. And to finish this off, I might perhaps draw an eyeball up here. Okay, so this is how we would see light reflected off a surface.